Hello everyone, in this video we are just going to print bitmap images onto our OLED display by writing the relevant scripts on Micropython in Tony IDE for ESP8266. Let's get started. So in this video particularly we are just going to try to print some image onto our OLED display. Before printing that image we just want to bring the image compatible with our OLED display. So we very well know that our OLED display is of resolution 128 x 64. So we have demonstrated printing text to the OLED display, and also we demonstrated printing graphics such as triangles, rectangles, horizontal lines, monitoring, pixel level displays in our OLED display in previous few of our videos. If you are new to this particular series, just go to those videos before coming to this particular video, because this is a continuation from the previous video. So in that video we just discussed about the schematic diagram also, using which we are just going to build the connection between ESP8266 node MCU development board and the SSD1306 OLED display. So if you are new to this series, please click on the link in the description of this video, or go back to the previous few videos before this particular video in this playlist. So before getting into the Python scripts, let's discuss in detail about the layout schematic that we are going to build for interfacing SSD1306 OLED display with our ESP8266 or with node MCU. So as we discussed, we are just going to discuss about the schematic diagram that we are going to build for interfacing OLED display with our ESP8266 node MCU module. So on the left you can see the node MCU or ESP8266 module, and on the right you can see the OLED display module. So this OLED display module is also available in an SPI communication format, and the one which we are going to interface is of I2C communication, that is inter-integrated circuits protocol. So I have explained in detail about this particular I2C protocol in a separate video. The link for that video is available below this video, and also you can find that video in the same playlist of this particular video before this particular video. So I hope that will also help you. If you want to learn in detail about the I2C communication, just watch that video before watching this, or if you are not interested in that, you can follow this particular video. So now let's discuss in detail about the connections that we are going to make in breadboard for communicating this particular display with our ESP8266. So you can clearly see I2C protocol has only two lines required for communicating. One is clock and one is data. So SCL right over here is clock, and SDA right over here is data line. And other two pins that are available in our OLED display is VCC and ground, which are helpful for powering up this particular OLED display. So this VCC I am just going to power up with the help of the power from the node MCU. I will be connecting the node MCU to PC through micro USB cable, and the power for that particular node MCU will be provided by the USB port of my PC. So I will be taking the same VIN power and I will be providing it to the OLED display. And ground, I am just going to connect the ground of the node MCU to ground of OLED display. So I have powered up the OLED from the node MCU itself. And clock pin, I am just going to connect it to D1 of the node MCU right over here. So I am just taking D1 for connecting the clock pin of OLED display, and data pin I will be using D2 pin of node MCU. So I will be connecting the SDA line of OLED to data pin. That's it. So this is the connections that we are going to do. We are going to power up the OLED display with the help of same power from the node MCU, and a clock pin will be connected to D1 of node MCU, and data pin will be connected to D2 of node MCU. So this D2 is nothing but GPIO4 in the script, and this D1 is nothing but GPIO 5 as per the internal naming of the GPIO pin. So we will be using this particular internal naming 4 and 5 in our Python script for configuring the I2C protocol. But external naming for this particular GPIO 4 and 5 is D2 and D1. So externally we will be making this connection as D1, D2, and internally in our program we will be using the namings as GPIO 4, number 4 and number 5 for D2 and D1. So this is the schematic that we are going to build, and let's write down our Python scripts for writing some text onto our OLED display with the help of Node MCU by building this particular schematic diagram. So only 4 connections will be made: VCC, ground, SCL and SDA in the breadboard. So I hope you just got to know in detail about the layout schematic that we are going to build for interfacing SSD1306 OLED display with ESP8266 module. So this is one of the program that we wrote in the previous video, where we just printed some graphics onto the OLED display. That is, we printed some squares, lines, horizontal, vertical lines, and pixel level printing process has been performed by us in the OLED display. Now we are just going to print a complete image onto the OLED display by converting that particular image into bitmap format. So for printing process, I have taken my logo itself. You can clearly see this is the logo which I will be printing on the OLED display. Before printing the image onto the OLED display, please make sure that the image must have the resolution of 128 cross 64 pixels. So this is a must have necessary. Using some online converters or tools like Photoshop or CorelDRAW, you can just convert the image into respective pixels and then come back to this process, so that you will be able to print the image onto the OLED display without any breakage of images. So this is a converted image which is having 128 cross 64 pixels in width and height. So for converting the image into bitmap buffer format of hex values in binary format, we have a tool. We have various of tools available in the web. I found one of the tool that is from this particular website. I don't know what this website is, but I have provided the link for the tool in my description of this video. So you can just directly download this particular software using this button right over here. This is nothing but Micropython bitmap tool. So I have installed this tool. Just install this. This is a very easy installation process. Just install that and open this, and I will show you the step-by-step method of converting this image into buffer format. Just select HSLB and then click on this load bitmap and select the image that you want to convert. In my case, I am having the logo image of mine with a resolution of 128 cross 64. Just click on this and open. Before this, you just want to convert the image into respective OLED resolution. Remember that. Open. You can see right hand side it has been converted into binary buffer format. Copy this. That's it. Close this and paste it right over here. You can just delete these things below. Until this you can delete, and above also you can just delete these things, and I'm just going to name this as SM logo. That's it. The buffer has been successfully filled and we have defined the buffer with a byte arrays. Let's start our Python scripts for printing this particular logo onto our OLED display. So we have configured the OLED display has been configured and it has been given to the variable display. I don't want this string function. I'm deleting this, and I don't want any of this. I'm deleting everything. Coming to the programming part, I'm just going to import another important thing or module, that is frame buff. This is an important module for printing the buffer values onto the OLED display. So here what I will do is I will just declare and define a variable called FB, and inside the frame buff I'm going to the instant frame buffer SM logo 128x64 cross frame buff dot mono HLSP. Please make sure this name is correct. Okay. After that, display fill with 0, display blit FB 0, 0. So we have varieties of options for this particular parameter right over here. We have mono, VLSB, HLSP. So this particular format is nothing but the most significant bit will be the 7th bit of the byte. So remember, this is the most commonly used format for any buffering of any display in embedded systems. So often we will be using this, and some devices, if you are comfortable, we will be using VLSP, which is like meaning like 0th bit will be the MSB. It will be like an inverted byte, and we are filling the display with the zeros, and we are loading the buffer FB. So this FB is defined with the SM logo 128x64 in the type of mono HLSP format of hex files. So this instance will be useful for loading the buffer in the variable FB, and this FB we are printing to the display with the help of blit instance. So this blit is useful for writing the buffer values onto the OLED display. So the total 128x64 pixels will be printed using this blit function. That's it. Now I have connected my OLED display to my node MCU as per the schematic that I explained just now, and now I'm just going to save the script, and I'm going to run the script by clicking on this particular icon or F5 in my keyboard. You can see this is the output which I got in my hardware. The SM Academy logo has been successfully printed on my OLED display without any glitch. So similarly, you will be able to print any logos onto the OLED display or any bitmap images onto the OLED display using the same method that I followed in this particular video. I hope you enjoyed this particular video and learned something new of printing an image or bitmap images onto the OLED display using Micropython scripts in Tony IDE on ESP8266. See you in the next video. Thanks for watching.